Alright, so today the main topic of today is polynomials. Okay, so it's really useful. Okay, so let's so last week no on Monday we had a practice on secret sharing using straight line. Okay, if you recall. So on Monday so on Monday we use straight line to hide the secret, right? So our secret is some number s, okay, and then we pick a random straight line, right? And then we give points on this straight line to people, and we know that if two people share this point, they can recover the line, and after you get this line, straight line, you can find s, and they can get the secret. Okay. How can we generalize this method so that suppose, so in this case we can share secret, right? Yes. So two people can recover s. Okay. Now, if I want more people, like if I want to change this from like I want 3 people, okay, at least 3 people has to combine their information to obtain the secret. What can you do? Can you use straight line? You can see if you use straight line, you only need 2 people, right? So you need a function that is more complicated, more complex than straight line. So you need a function that basically, if you know 3 points on the function, you can recover the function. But if you only know 2 points, you have no idea what the function is. Okay? So 3 points for 3 people. You need, like in the straight line case, you give points on the straight line to people, right? So if 2 people try to recover the message, they can do that because they have enough points on the function to recover the function. When they have the function, they can find s, right? So what are the functions that if you know 3 points, you can recover the function? Okay, so this is a polynomial degree 1. Okay, a straight line is polynomial degree 1. What is the polynomial degree 2? So if you have a polynomial degree 2, what does it look like? It looks like it's a parabola, right? Okay, it's of the form fx equals ax squared plus bx plus c. Okay? If you have a parabola, okay, if you have a line, so let's make it look like that. If you have a line, if you know 2 points on the line, you can actually recover the line. It's polynomial degree 1, so fx equals ax plus b. Now, if you have a parabola, how many points do you need on the parabola to be able to recover the parabola? So in fact, you need 3. So you know 3 points on the parabola. There will be just one parabola that go through these 3 points. Okay? So you need 3 points. If you have a higher order polynomials, so if you have, so this is polynomial degree 2. If you have polynomial degree 3, it would look like, polynomial degree 3 would look like this, maybe that. Now, this is folklore. We prove that later. But if you know 4 points on a polynomial degree 3, you can recover it exactly. Okay. Now you can generalize, right? So if you have degree 5, how many points you need? You need point. Okay, so if you have polynomial degree d, you need d plus 1 point to recover it. Okay. Now, if we wanna find a secret sharing scheme using this kind of polynomial, okay. So suppose we have a secret here. Let's try to think about it. So if we have a secret s, which is where this function intersect with the y-axis, okay, and we pick a random polynomials with that property, exact property, and we give people points on this polynomial. Okay, how many people is needed before they can recover s? How many people? Suppose I have 10 people in my team, and I give each of them 1 point on the curve. Okay. So now, if 3 of them come up, 3 of them, wanna recover s, they can, right? They can join force, and then they have 3 points on the polynomial, like maybe this guy, and that guy. They join force, and then they can recover s. Okay, so this is the idea of the secret sharing scheme. So the idea is like we have, if we want k people to be able to recover the message, we pick a polynomial of degree k minus 1, right? Because a polynomial degree k minus 1, you require k point. Okay, so if you can do that, then you can do the secret sharing scheme. That's the whole idea. Okay. But how are we going to do that? We'll see. We'll see how we do that. Okay. So the idea is like this. So we need if you have polynomial degree of degree d, you need d plus 1 points. So the secret sharing scheme is like if you want k people, so you pick a polynomial of degree k minus 1. It's like last time when we want 2 people, right? So we use polynomial degree 1. Okay? Alright. So the application of this is secret sharing, and also there are error correcting codes that use this kind of like principles to come up with error correcting codes. Okay, so this is the basic fact that we use, and we prove some of this. So you should be somewhat like familiar with this, with some of this. Okay, so if you have a polynomial f, we say that a is the root of this polynomial. If you plug in a to f, you get 0. Okay, so it's 0 at the point a. If you look at the graph. So the polynomial might look like this. I don't know. So its root is gonna be this point, and that point. Okay, that's where the x value is. Maybe this is -1, this is like 5, this is 10, stuff like that. Okay, so these are the roots of the polynomial. Some polynomial might not have roots, like this one. Okay, doesn't have any real roots. But you look at the complex number, then it also has a root. It has complex root, but we will not go into that. Okay, it's really hard for us. Okay, so the property of the roots and polynomial is that we require is basically this. So a non-zero polynomial of degree d has at most d roots. Okay, if you have polynomial of degree d and it has more than d roots, it has to be a 0 polynomial. Okay, to see property 1, think about this. If you have a parabola, right? So parabola would look like this. It can have 2 roots, right? So if you pick these 2 roots, it might look like this. It might look like that, right? But if you require it to have 3 roots, there is no way for it to like, if I go up like this, parabola would look like this, right? Go up and then go down, right? But if this is a root again, then it has to go up like that, right? But this is not a polynomial degree 2, right? It has degree 3. So the only way you can do that is like you have to like be completely flat, right? Like so it has to be like flat. So it's gonna be 0. Okay. So a non-zero polynomial degree d has at most d roots. Okay. And also, if we know d points, if you know d plus 1 points on the polynomial, you can find the polynomial exactly. Okay, if you know that polynomial is of degree d, and you know d plus 1 points on it, there's only one polynomial degree d that satisfies this. Okay. Alright? And this is like this is the thing that we use when we want to do recover the message in the secret. Okay? How are we going to do that? We will see. So the proof, I'll go back to the proof later on. Okay, let's have some fun first. Here, today we're going to use, so we can think of polynomial in terms of like in real numbers. But today we're going to use polynomial over the finite field. So we perform everything modulo 11. Okay, so when we perform everything mod 11 and we use integers, so it's going to be work on the finite field. We call it finite field. So modular arithmetics usually deal with finite field. So if you mod 11, so it's a finite field mod 11, GF11. So what we have is GF. Today we use GF11. In the exam maybe you might mod something else. I don't know. But today we mod 11. Okay. So how does it look? Okay. So let me show you the graph. So so let me define a new function. Let's say f, function f. So let's modulo 11. Okay. So let's pick a degree 2 polynomial. So let's return 3 times okay, so that's the polynomial that we have. I do everything mod 11. Okay, so let's see the value that it has. So for I in okay. So it's a parabola. In real number, it's a parabola, but when you do with modular arithmetic, you have numbers that goes up and down. So start with 9, 6. It looks pretty crazy, but it's in fact it's a parabola. But you modulo it, so it's go up and down. Okay, so it looks pretty weird, right? If you want to plot it, like why you start with 5 and then 6, 5, 7, 0, 10, 4, 4. That's pretty crazy. Okay. But this is how it looks. So let's see the actual parabola. So the function itself look like this. Okay. So the function itself look like this. If you plot it, it's gonna be like like typical parabola. Okay. But if you mod the whole thing, you get exactly the same thing, okay? But this won't show you the actual functions. So let me try to plot it, and let me go slowly from 1 to let's say to 5. Okay, so you see the actual function. So do you see how it looks? So the parabola will look like this, right? But when you mod, it's go down. Okay, and it's like this is like each of these will be part of like the parabola. So the parabola actually look like this, but when you mod, you cut it up into pieces. Okay, and at the location when it intersect with the integers, like this is 9, right? And then the next one is 0, stuff like that. So this is actual function that it looks. It might look like pretty crazy number when you do the mod with the int, but actually it's just a parabola. Okay, it got cut into pieces because we do the mod. Okay, so that would be how it look. Okay, so if you look at this, 1 is 6, right? So 1 is 6, so it's probably 1 versus 1. So this is 1, I think. And then the next number is 9 and 2, right? So it's gonna be like here, I think. So this is 2. And 3 is like 7 will be out there somewhere. Okay, because my number is only go up to 2 something, right? 2.6. So let me. So it's gonna look like this. Alright? So there's no, the function is not going down like this. It's just a mod. So it's go up there and then go down. So, alright? Yeah. Alright. So if you have a polynomial, what can you do? The first thing you can do is you can evaluate. Okay, so if you work on GF11, if your polynomial is this, we can evaluate them into to see a point. This is what we just done. Okay, this is actual value. This is the value modulo m. Okay, this is what you do. Today we will learn the other way around. Okay, so we have polynomials p. You put in points, and you get px, right? Today we will learn. Suppose we have p1, p2, and a few other points, and we put it in some process, and we get p back. Okay, so this is called evaluation. This is called interpolation. Okay, this is what we will learn today. Yeah, okay. But let's see why we do that. Okay. All right. So okay. So we do secret sharing scheme. Okay. In the practice, okay, the setting is this. You have n people, and you have secret. Is you want to share is so that there will be some other numbers called n or k. Okay, k has to be at most n. So we want to share s so that any group of k minus 1 people cannot know nothing about s, and any group of k people can get s back. Okay, what you do is the following. Okay, so we'll pick secret s, right? So we pick random polynomial of degree. We want k people to be able to recover the message. Okay, so what's the degree of the polynomial that we need? เราอยากให้k คนเอา message กลับมาได้ครับต้องใช้ polynomial degree เท่าไหร่ครับ So we give each people a point. So we want a polynomial that can be recovered with k people. So the degree of the polynomial would be. So if you want 2 people, the degree would be 1, right? If you want 3 people, the degree would be 2. If you want k people, the degree would be k minus 1.
Okay, so pick a random polynomial degree k minus 1 such that, let's call it f, such that f0 is s. Okay, so the polynomial would look like this. So this is your message, and the polynomial would go something crazy. Okay, but it is passed to this, and then you give each people the points on the polynomial. Give person I some point xi and fxi. They have to be different points, otherwise they cannot combine and get more points. Okay, this, and then that's it. This is like what the each people would get. Okay, this is a scheme for passing the secret. Okay, okay, all right. So let's try to do that first in the exercise. Okay, let me do more things. Okay, so after k people join force, if you have a group of k people, if you want to get s back, what do they need to do? They need to recover the function f. Okay, if they can get f back, they can evaluate f to get s at point 0. Okay. All right. So let's do that on the exercise. Again, now you work with a pair, another student. Okay. If you have a group of 3 people, then you should somehow do it in circle. Okay. Okay. First part, you have to come up with a secret and the polynomial. So let's pick some secret. So pick some number from 0 to 10. Again, we mod 11. Don't pick 0. 0 will be too easy. So suppose I pick 5. Okay. And then okay, we want a polynomial of degree 3, I think. We want a polynomial of degree 3 or degree 2. Sorry. Okay. Well, because you get how many points you add to people. 3 points. Okay. Okay. So you want a polynomial degree 2. Okay. So this is, just ignore this. Polynomial degree 2. You want a polynomial degree 2 that if evaluate at 0 gives you 5, right? So P has to be some form like PS equals 5, because the other terms will have x in it. When you evaluate at P0, you only get 5 on this. Okay, and then we want polynomial degree 2 because we want to give your friend 3 points. Okay, we 3 people will be able to come back to recover the message. Now, you should pick 2 random numbers. Okay, some random numbers times x squared plus some other random numbers times x. So this should be the first one. The first one should be 0, because since the first one is 0, your number will be of degree 1. The function will be degree 1, which is like too small. Okay, so this should be non-zero. This can be 0, but can be something else. Okay, pick some random numbers of this from 0 to 10. Okay, don't tell your friend about this. This can be 0. This is your message. Okay. Also, don't tell your friend about the message. Okay. So suppose I pick. So let me be lazy. So let's call it. Okay, suppose I pick that. So this is my polynomial. Okay. Now let's evaluate it. Okay. Let's evaluate it on these 5 points. Okay. Suppose I want to give I have a team with 5 people. Okay, so these are the points that I give you, my friend. So the first one we get the point at 1, 2, 3, and 4, and 5. So I evaluate this function p modulo 11. So I plug in. You should use calculator or whatever, but you can do it by hand. Okay, so you plug in 1. So this will be 1 plus 2 plus 8. Okay, so this is the points. So this is like what we did here is the following. So we have some polynomial p that goes to the secret s, and then it's polynomial degree 2, but it will look crazy like this. And we evaluate 5 points on it. Okay. And now we give this 5 people 1 of the points. Okay, so this is the first step in the secret sharing scheme. And then suppose 3 people wanna recover the message. What would they do? Okay, so the next step is that process. So you should pick your friend. So the 5 points that I have in my case is like 1 8, 2 2, 3 8, 4 7, and then 5 1. Okay, then you should pick. Now you should give your friend 3 of them. So it's like 3 people try to recover the message, right? So maybe you should pick. I don't know. I just pick maybe this, okay, and give this to your friend, okay. So don't give your sheet to your friend, okay. Just give them the 3 points so they can write it down on this page, and then we'll come back.